Okay, I wanted to give you a quick walkthrough of Sage and CoCalc. Sage is a mathematics environment that sits inside CoCalc. CoCalc can do other things. It can host other kinds of activities like the R statistics package or the LaTeX word processor, but it can also let you work with Sage. If you go to a CoCalc server like the one at Whitman College, you can create an account and then sign in under that account name. I'm going to do that, signing in under this email address. When you sign in for the first time, you need to create a project. I have 3 projects going here. The project for the course that I'm teaching this semester, and then a project for Sage examples that I'm building for students in that course, but also possibly for students in future courses. You create the project first, you click on this button and go through that process, and then once you create the project, then within each project you create files. So I'll let you figure that out. Go ahead and create a project if you want to follow along. I'm going to click through on Calculus 3 examples. And if you click through there, you see some of the files that are associated with this project. These are examples that I've already developed for students in this class. Let's do a little demo of the CoCalc interface and working with Sage. Go up here and you can either click New here or New here and you'll get the same dialog. If I click New here, I'm asked to name the file and then to tell it what kind of file it is. Is it a Sage worksheet? Is it a Python Jupyter notebook? Is it a LaTeX document? What is it? Make sure that you tell it that it's a Sage document because that's what we're talking about here. So this is a demo of Sage, and then click the Sage worksheet. And that drops you into this interface, which seems pretty spare, and it does require a bit of a learning curve. This is a cell. Within a cell, you can do a number of things, but you issue commands, and then you execute those commands by either clicking Run or hitting Shift Enter. Shift Enter. And let me show you what I mean by that. I can add, say, 2 plus 2, and I'll hit the Shift Enter key, and it'll go off and think for a little bit, and then it'll come back with the answer. I can do more complicated things than this. For example, I can declare a variable and then work with a variable. Say I'll declare a variable t like this. And then I can make an expression, say f of t, say t squared like this. And now if I show f, I see that it contains the expression t squared. All right, so this is an input box and this is an output box. I can hide input boxes if I want. I can hide output boxes if I want. If I click on these little arrows, they collapse and uncollapse the input and the output. If I decide I want a new input right here, I can click on this gray bar, and that'll give me a new input cell where I can do other things like g is equal to 2 times t plus 4. And then it's nonlinear. It's just these variables and these commands are just whatever has been most recently executed. And remember to execute, you just hit Shift Enter. So let's see what G contains. All right, and if I go down here and I change G to something else, like G is equal to 4t minus t squared, and then I go up here and show G again, it's different. So the order of the cells doesn't matter. It's really just the order in which they've been executed that matters. All right. Now, executing mathematical commands is not the only thing that you can do in one of these cells. You can also include comments. There are a couple of ways to include comments. I can do a hashtag at the beginning and say this is a comment. And then when I execute it, nothing happens. Anything that starts with a hashtag is ignored, and I can even put a hashtag in the middle of a command like here's a new T, a new F, 5 times T. So now I've executed this command and then it ignored everything after the hashtag. And if I show F now, I see that it's 5T. Sometimes the hashtag isn't good enough. It only gives you ASCII text, like in a text message or something. If you want something more sophisticated, you can use a thing called Markdown. If you type %Markdown and then hit enter, you can now start typing Markdown commands. And let me show you what Markdown is. This is a standard way of formatting text. I always go to the Markdown cheat sheet, and it shows you how to, let me just click on the first link here and hope that I get what I want. So I can define headings. I can do boldface text by doing double asterisks, italics, block quotes. I can do ordered lists and a whole bunch of other things. What does that mean? Let's show an example. So if I do a single hashtag and then say Markdown examples, and then I hit Shift Enter, the output is a very large header that says I'm doing Markdown examples. If I go back and I do a second hashtag, it'll be a slightly smaller. And if I do a third hashtag, even smaller. This lets me build nice comment sections. So here's a Markdown example. Here we demonstrate various Markdown syntaxes. Here's something in bold. Oops. And here's something in italic. All right, and lots of other things you can do with Markdown, and I suggest you just scan the Markdown cheat sheet to get an idea of how to play around with that. All right, so that's Markdown. Some of you may be familiar with the mathematical word processing software called LaTeX, and this also understands LaTeX. So if I go into Markdown mode and I want to do a mathematical expression, I can use LaTeX commands like f of x equals sine of x. So the $ indicates that I'm starting LaTeX input, and then these are just LaTeX commands that I know, and I hit Shift Enter and I get a lovely mathematically typeset function. It can do other more complicated things. For example, we could do an integral. Here's a difficult integral. Int subscript 0 superscript infinity e to the minus x squared dx, and I see the text that I wrote, and then I see a nice version of the integral. The double $ makes the mathematics centered and sort of larger. If I don't want to do that, if I want it to be in the running text, I can use a single $ around the LaTeX command. And well, it looks like I get the same thing. So who knew? All right, so that's LaTeX. You can go learn LaTeX. If you want a free LaTeX account, you can go to overleaf.com And not only does this let you do LaTeX in the browser, but it has lots of tutorials and templates. All right. You've seen a lot of the interface now. Let's talk a little bit about the function. So this is an expression. If I show f, for example, it's currently set at 5t, and you might say, oh, I wonder what f of 2 is. And if I type f of 2, I get an error, or a warning anyway. So it did kind of the right thing, but it's really not what you're supposed to do. This is an expression. F in this case is an expression. It just stores the variable, stores the expression 5t. If I want to evaluate it at t, I should use the substitute command and say t equals 5. Or t equals 2. I think it was 2 before, excuse me. Yeah. All right, so that's what you do when you want to evaluate an expression. But what if we want to use function notation? Well, we can actually define a function like g of x. Let's define a variable, x. Anything that appears on the right-hand side of an equal sign in Sage, you need any variables, you need to declare them. So we'll say g equals x squared, like that. And let's show g. Looks the same as an expression, but now I can evaluate that at a number, and I get 4. 2 squared is 4. Or I could evaluate it at a more complicated expression, like g is equal to 2t minus 3. And it knows how to do that. So that's an expression versus a function, and sometimes you might want to use one versus the other. We can differentiate functions and expressions. For example, we can compute the derivative of g. Let's store it in the variable dg, stands for derivative of g. We use the diff function and g of t with respect to t, like that. And then let's show g. That's x squared. And let's show dg. dg is 2t. Where did that t come from? Well, I took the function and evaluated at t, and that gave me an expression involving t. Then I differentiated that expression with respect to t, and I got another expression, dg. Okay, we can integrate functions. For example, we could integrate dg with respect to t from 0 to 1. And if I run this, it's going to go off and do work, but it's not going to show me the answer. And you might find this frustrating. Sage is a relatively quiet function. Actually, it does show me the answer in this case because it was the last command in the block. It always shows me the output from the last command in the block. But if I do 2 commands in this block, and one is the integral from 0 to 1, and the next is the integral from 0 to 2, and I execute them. Oh, wow, it's actually working. Oh well, I take it back. That seems fine. Sometimes you have really massive expressions, like I'm just going to create, let's do a trig identity. And let's do sine of t squared plus cosine of t squared. And let's show trig. Cosine squared plus sine squared, can we simplify that? Maybe. Let's do trig.simplify. Didn't do much there. You can tell it to simplify even more aggressively with the simplify full command, and I almost always use simplify full. If you simplify full, then it knows what to do with those trig functions. So you take the expression, you append this little command, .simplify full, and it returns a new expression that is the simplified version of the old expression. I almost always use simplify full instead of simplify because simplify full tries all of the things, and usually that's what we want. So simplifying is good. You can also solve equations. For example, what's g right now? So g is currently x squared. We can solve g of x equals 0 for x and see what that gives us. It gives us one solution, x equals 0. We could also set it equal to 4 and solve, and we get two solutions, -2 and 2. So we can solve equations algebraically using Sage. We can also plot functions pretty easily. Plot g of x, x from -2 to 2, like this. So the syntax is g of x, and this turns into an expression, and then this is the variable that I want to plot and the range of the variable. If I hit Shift Enter, I'm going to see the nice parabola.